All right, what's up, guys? Today I'm gonna talk about question 140, and the question is: we're given a string and a dictionary of smaller strings called word dictionary, and we want to find all the possible combinations that we can break up the input string using only the words inside the dictionary. And the one simple idea that we can think of is using DFS to break up, to find all the ways that we can break up the tree, break up the input string using the dictionary, the words in the dictionary, and that way we can find all the combinations. But uh, one observation is that we're doing this repeatedly because, for example, in this case, some words are being let's say in this case, so the first pi is being used multiple times, and because of that we don't want to compute uh, the combinations that comes after pi multiple times. We can just look it up. So because of that, we can use that hash map data structure to store this kind of information. And how we're going to retrieve the substring that we have already found is using the index of the starting index of the substring. And yeah, let me code this up real quick. So first we need a set of strings that can keep track of all the so we can find whether a substring exists inside the dictionary or not in O1 of time. So iterate to the entire word dictionary and set that at word. Also, we need a map that keep track of the starting index of the substring as well as all the combinations that we can compute with the substring starting at index um, specified as the key. So it's a list of strings. And we know that there's one corner case is when the index here reaches the end of the input string. We know the result is empty, so we can add that to the list right away. So add as the length. So when we're at the last element, we know that um, the substring is empty. So we'll just add the empty substring here, and then we just run DFS and return um, the result. So that DFS will need the string, the index that we're currently looking at, both at the map and the set. So here we'll return a string of DFS, string s index, and map as well as the hash set. So if by looking using the index, if the index already exists in the map, we can just return map.get index. Otherwise, we need to build a solution for this current solution. So we'll just call it then we'll need to iterate through all the possible substring combinations. So starting from index. And then define a substring. It's, it's equal to as the substring of starting an index and anywhere between index and I plus 1. And if this is a possible solution. We know that we can find, we need to find everything that comes after it. So the solution of everything that comes after it. So let's call it lookup. So we'll use DFS to find everything that comes after it by passing the index of I plus 1 and the map and the set. And at this point, if we after executing this line, by recursion, we should get all the possible sub-solutions starting at index I plus 1. So now we just need to iterate through all the solutions inside the lookup string. And we know all the combinations here are a valid, are a possible solution. So we'll just need to add that to our current solution. We'll add substring plus st plus if str is so there's a corner case because there's going to be a space in between each character, but no space at the end. So if so we need to check whether the lookup string is empty, and if it's empty, we will not append a space in between. So if look up the size is equal to 0. If that's true, we will just append the empty space. Otherwise, we'll add the empty space. Add empty space and plus the current solution that we're looking at. And after the for loop, we can just we know that we have found the solution for the current index. So we can just populate using index and the list. What we can do is we can return the solution here. This will do. This is not a hash map, it's a hash set. Map dot line 13 dot put. Okay. So what's the problem here? The problem is we do have extra space appended. So yeah, this is where I'm a little not sure about. So in what case are we not adding a 0? It is the case where we know that it is this is the last element. I think it's the last substring, meaning we're looking at the last. Well, our index is pointing at the last element, and because of that, we don't want to add any spaces. Yeah. Okay. So yeah, this will work. And for time and space complexity, let's see. So here we're iterating through the entire string once. Let's say the length of string is n. The time complexity here is O of n, and um, so and space-wise, we're storing all the sub-solutions in the map here. So the map is taking a space of hard to analyze here. So the worst case of the map, it will be basically the number of solutions. So this is a space of map, and the set will have a space of O of k, where k is the size of your dictionary. So if we add this together, I think the most space that we're going to spend is on the map here, and for time complexity. Yeah, so I think we need to draw a recursion tree. So on each level, um, um, so we're calling this DFS exactly once for each possible substring. So I think is it just for time? The overall time is just O of n. So time is O of n, and space is O of number of solutions. All right, thank you so for watching.